Hi everyone, this is the second video for the HEC-HMS model simulation and calibration. In this video, I will continue to make demonstrations for the required jobs for running the HEC-HMS model, mainly with the model parameters setting for each method we had selected. So continuing from the previous video tutorial, I will expand this Bayesian model. So after that, if you click this sub Bayesian 9, and then if you click this loss method, loss tab, you can find these two required values for these loss parameters for the curve number as well as impervious percent. How about transform method? Also required these two parameter values. Base flow also required these values, okay? And other option, just ignore with that. So for the loss method, we need to insert this curve number. So actually, we need to calibrate after some jobs for this model. But basically, I will insert this one with this 80 with the curve number. After that transform method, I will also insert 3 hours for the time of concentration. It depends on the watershed sub-Bayesian areas, but I will just insert with this 3 hours and storage coefficient with 2 hours, okay? After that, how about base flow? Base flow things. Initial discharge would be, I will just use 1. And recession constant, I will use 0.2. And then you need to check this threshold time with ratio to peak. After that, just 0.4 would be start from the hydrograph with the base flow, okay? So all these kinds of the required parameters should be inserted to execute this developed model. So if you click this S10, also you need to insert this one. I will check another things for this reaches. So if you click this R7, reach 7, you can find this masking method is assigned. So if you click this routing tab, you can find this masking K and X also required to insert with some parameter values. So I will basically insert with 0.5 as masking K, and masking X I will use 0.25 with the default value. Then just ignore these options. Also, all these reaches required to insert all these values for this one. If you check the junction, this is not required any the values for the parameters, okay? So I just inserted this first sub-Bayesian with the loss transform and base flow values with the my default value, and also this R also I just inserted this default value. So based on that, if you click base model and then go to these parameters to insert all the parameters for this sub-Bayesian with the loss method, transform method, and base flow method, and other reach for this routing method with this masking method. Firstly, I will select this loss method with SS curve number, and then you can see I just inserted this curve number 8 values on this each sub-Bayesians. But in this case, I will just use all these curve numbers at once on here, okay? So if you adjust this one like this, and then if you click and drag all the table values and then right click, after that just click fill. And then you can find the table fill options. I will repeat the first value, so click OK. And then you can see all the 8 values for curve number is just inserted on this one. So we don't need to insert this initial abstraction. If you want, you can do, but I will not insert this one. After that, apply this one. And then I will make another parameter assigning for the transform method with the clock unit height graph. So if you click this one and then just expand with this window. After that, I will also select with these two and drag all this selection for the tables. After that, right click, then fill with the repeat first value. So click OK. So I just insert these my default values for this one, this clock transform method. So also apply. And then another parameter required base flow with the recession method. We also selected the last video for this recession method for base flow, and then just expand around to match this one. After that, you need to insert the same manner. So drag all these blank table and then right click and click fill with repeat first value. Okay, and also ratio to peak also need to right click, fill, repeat first value. So okay, and apply. And lastly, I will also assigning this routing Muskingum value for the reach. So if you expand this one, you can see this one. Already I inserted this one of the reaches. With the reach 7, I already inserted this default value, and then select all these required table and then fill repeat first value. Okay, after that apply. I will calibrate the model with this all these my default value. Okay, after the initial learning. Okay, so close this one, then recession also close this one, and clock transform method close. Then curve number we just assigned 80 for the curve number values. Okay, so apply. Okay, so expand. So I just assigned all the required parameter values for this Bayesian model. So if you check some Bayesian on here, you can see all the assigned the values for the parameters. Okay, and how about another Litchi? So you can see also this the default value is assigned. Okay, and the next thing we need to create before the model learning would be this control specifications. So if you go to this control specifications, you can create a new control specification. Also, you can click this component button and this control specification manager. Also, you can click, and then if you click this new button, you can also create this control specifications. So I will use the name of this would be control 1, and the description would be simulation of 2014 August event in Yongdam-Dam. Okay, so create this one and close. After that, you can find this control specification folder is just created on this Explorer window. If you expand this one and select this control button, control 1 button, you can see this required tab to insert with some the start date and end date. So before assigning required box, I will change this time interval with 1 hour. And then the start date and time would be 17 August 2014. Also, end date would be the same with the rainfall event as well as the discharge for the outlet point. So 12 o'clock and also 12 o'clock. Okay. So after that, again, if you click, you can see this well inserted this start and end date for this control specifications. Okay, so go back to this Yongdam Dam folder. So I'm ready to run this Yongdam Dam HEC-HMS model. So far we developed this Bayesian model and imported this terrain data, and also we created this time series data with this precipitation gauge as well as discharge gauge, and then we developed this meteorologic model with this specific histogram method. Then finally we made this control specification with this simulation of 2014 August event in Yongdam Dam. Okay, so after that, if you click this computer tab, you could not see anything for here. So after that, if you click this computer tab button, and then you need to create this simulation run. Also, you can use this simulation run manager like this one, but in this case, I will just use this simulation run like this one. And then, firstly, you need to find this required 4 steps of the creation of simulation run. Okay, so for this one, just name would be run 1, and then just click next. And then you need to select a Bayesian model. Okay, so we have this Bayesian model for Yongdam Dam, and click next. And then the third step would be select the meteorologic model for this Bayesian models. Okay, so we already developed this MET1, and then next. Also select Bayesian model and meteorologic model and MET1 we already done, and also simulate run include control specifications. So select one from the list below. This one, control 1, we just created one. So just finish. After that, you can find this simulation runs folder. If you expand this one, you can find this icon for run 1. As well as you can also find this button is activated. This would be compute all elements button. Okay. And also, if you can see this component editor window, you can see this simulation run is associated with this Bayesian model, meteorologic model, and control specification we developed so far. Okay. Also, just check ratio and states, just leave as a default. At this point, how about check this result tab? In here, it is also created this simulation run, but we don't have any run activated one. So after model running, you can find that is activated. So on here, right click, you can compute this one. Also, you can press this button. So I will use this compute button on here. So after that, you can see this finished model run with the run 1. Then you can see this start and end time for that. Okay, so close this one. After that, go to this result tab. If you click this one, you can see this learn one would be activated. So I will check very endpoint with outlet. If you click this one, you can see this new graph and summary table. So if you click this summary table and adjust this one, you can see this summary table, and also if you click this one, you can see the simulated hydrograph on this watershed. Okay, so this would be, this black line would be the observed data, and this blue line is the simulated stream flow for the dam inflows. Okay, also you can see this time series table, so you can see all the related data for this hydrograph. You can copy and you can use for another spreadsheet if you want. So close this one, and also you can find this summary data as well. Okay, so on here you can also find this residual and combined inflow as well. So based on this simulation result, you can find this again, this observed data and simulated data is not well matched. So you can clearly see this residual flow for that. So we need to calibrate model to match all these required observed data for the simulations. So for that, we need to change the parameter values. So go back to this component tab, and then if you click this Bayesian model icon, and then you need to select this loss and other transform. For example, you need to change all these values to calibrate this simulated the stream flow. Okay, so close this one and save this processed older job on this project. Okay, so in this video I have made a HEC-HMS model simulation with the parameter assignment and created components for executing the model. After model run, we can see the results and compare model output with observed flow data. Then the other required model calibration processes to match observed and simulated flow will be continued on the following part 3 video. Thank you for watching.